think you guys are going to like today's lesson.
Is it easy?
I think so. And that's not just coming from a math teacher. Nope. Amanda, were you done? I forget. Were you done with your quiz or not yet from yesterday? I couldn't remember.
From yesterday?
Yeah.
I didn't do 2 of the questions, but I don't know how to do them.
Okay.
And so,
I graded it. If you want more time, just come see me and I can adjust the grade.
okay.
That deal?
Yeah.
Okay. And I apologize if you were like, dude, I wasn't done and you graded it.
No, yeah, I told you to grade it, but
I couldn't remember.
no, yeah.
So, but it's graded. And if you want to do those 2 questions, like next week sometime,
Okay.
totally. And then we have that quiz that you still need to make up.
Yeah, I really do. I was gonna take it today, and then I went to IKEA and I forgot.
You went to IKEA?
Yeah, I went
And
to
you
IKEA.
made it back in time?
I went to IKEA and Party City.
Oh my gosh.
I know.
Hey.
Wow.
Yeah, because I have 2 kids that are on 5th and 6th off. So I went to IKEA, I got
thought you
2
did,
hot
like,
chocolate
groceries.
ice cream, and then I went to Party City and looked what I got.
Oh my goodness.
Love them, but sometimes. 350 Peppa stickers for $3.
Hello.
You want one?
Yes. Absolutely.
Can I?
For how many dollars?
350 Peppa stickers for $3.
Oh, I thought you said $300. Like,
No.
that's so
$300
not worth
for
it.
stickers. Oh my god, there's so many. Yes. Give.
They have chocolate toys at a church.
Miranda's missing out today. She went to Copper Mountain. Now she's not at Peppa.
And like the little kids never get out.
Were you at lunch? No, you weren't. So I came back from my class to sit some guys and shit, and I just ran up to Mark and tackled him. It was great.
Cool. I'm gonna decorate my
Oh yeah, no, it's like candy.
my notebook.
Yeah, come on up anytime. But you can come into other my
Oh,
operates
coffee
as well.
looks so good.
Yeah.
I want to go to practice.
I always have the note on my door when I
I
go up there.
can't drink my coffee.
Or, I mean, you can go, it's Tuesdays and Thursdays up there. You can always go up there and just say, hey, can I get some extra help? Or you can come see me.
No regret.
If I'm not there, you can come see me, or you can have one of those teachers up there explain it as well.
The teachers are there very
Definitely making the
Where's George
test next week.
Okay. We'll make it work. I'm not worried. I'm not crying myself to sleep, I promise.
Chris, look what I got at Party City.
Ooh.
It's 350 Peppa Pig stickers.
Open it up.
It's 348
Are they all
now. No, there's like different pages. I know.
Best day ever. Hey,
Really?
Monday during 2nd.
Monday 2nd.
Can you help me with midlife crisis?
Yes.
Okay. This class is my midlife crisis.
I hope you're not in the middle of your life yet. You're too young. I'm the one who's buying the Corvette.
Woo!
Hey.
No. I know. I need to find one I really like.
Oh, that's right.
Really passionate about.
Oh, this is a good one. I do like that one.
That's like a French one. That's pretty good.
Did you just say you failed it? I got a B minus.
I got ice cream, guys.
Please.
That's
Oh, wait, how did you get?
Thank you.
I don't even know what.
Thanks.
What?
Sorry.
You're good.
No, not sick. You got a B
I don't know if
minus.
friend's the right word, but
That's the good
Wait, did you go?
that's a better word.
Yeah, okay. I studied with friends last night and then I came back.
Did you feel tired?
No. Okay. That was my
Are you a Chad or are you a Sam?
Oh my god.
It's either of those.
Sorry.
Sorry, you're a simp. You're gonna have to report you to Goose
A
Guy.
lot better than I thought I did. I'm not.
Poison for Goose Guy, Goose Guy's poison. Oh, yeah, I got it right here.
I got a 6.
Zima, isn't her name Zima? Or something, Vizima? Do you remember?
Yeah.
Who? Could you look it up on a miracle device?
Yeah.
Look up what? The name of the villain in
Oh, yeah.
Emperor's New Groove.
Last semester I knew it was happening.
You have a miracle device? I don't have it with me.
Wait,
My
who's
miracle
the big
device is
dude
only
in Emperor's New
14%. Kronk.
Chrome.
And I can do his voice.
I like this one.
Yeah.
Like, if it is.
Poison. Goose. Give me the poison right here. Yeah, I've got poison. Wrong. No, I want it. No, it's my birthday. You broke it. It is my birthday. Yes.
Happy birthday.
So mean.
Hey,
You never believe me.
Megan, look what I got. Do you want?
My thumb hurts. Yeah, gotcha.
There's so many.
Oh, I want this.
Sarah, I'm really sorry. During 6th grade, my mom told me I had to go home to let out my dog, so I couldn't come in.
Okay.
But I will on next week. I'm sorry, Annie.
Mr. Sherman, I gotta hit the bathroom.
Okay. Inappropriate.
There's three
This is a
50
school.
for $3. It's a steal.
Yes, it is. Yes, it is. This is church. You need to be respectful in God's house.
Perfect.
You're gonna be featured on
Yeah, I have it.
Hey, Sarah!
Yeah.
School is the same thing as the Ashkenazi, which would say shul, which in Yiddish means place of worship, or
Ew, what the hell
quite
is
literally a
this?
place of worship, because that's what Jews think listening to the Torah is.
Ew, poopy.
Uh-oh, stinky.
Ew, half the time was.
Just not real things. Hey, you watch it. I've learned the real things in
Nah.
church. I mean synagogue,
What if I did?
shul. I went to
Everybody should make sure
you
their
seem like
pants
an
are
anti-Semite.
I have an announcement
Yeah,
to make.
prove it. Prove it. Think it's give me $20. Give me $10. Give me all your money. You need this. As it was the why.
Oh, that was a good time.
I as a Jew, I'm giving you consent. If you refuse, you don't consent. If you accept that, then you're a Hitler. You have no choice unless you give me money.
Can we go outside? It's so nice today.
Can we go on a walk for like mental health purposes?
Could I please finish my test? Can you make sure
But it's not that class.
Okay.
Yeah, so if I only Jews can get on this card. This card is metaphysical. Anyone who holds this card is no method Jew can be used
That works for you.
unless it's anybody other than Jews. Chief rabbis of every country.
Next time, my friends is sick.
And if you are, and if you bring your appeals before
You actually
sufficient for us to take it back, or the court of appeals, the Jewish court of appeals can take away the person and you have unwittingly given.
Oh, yeah.
Megan, I give you one, but it takes about 3 years.
Big notes today.
Sorry, I'm already Jewish.
You actually killed a
Oh,
tree.
well, that's a whole history with you.
Whoa, what the? I got white.
Jewish?
You're
This
a liar.
a little serious for me.
You're a liar. You're a damn liar.
Hey, Sterla, do you have like wipes? Cause someone like, there's grape everywhere.
Just grab that rag that's in that pink thing and then squirt some sanitizer on it.
It's not a salary. Isn't salary like being paid for a particular amount of time?
Question, where's
And
the
we ran to
sanitizer?
the side downstairs.
On the desk.
And then
Because it's on the
after we
notes.
ran through everything, we got hot dogs on the screen.
This is how exasperated I am.
Sorry,
Looking.
friends.
I can't stop looking.
So I
Okay, friends. So quite a few of you have been coming in to finish up the test. Just a reminder that some of you have not only yesterday's test but other opportunities as well. So let's get those, start getting those in the mix of things, if that's okay.
Hey, Star, is this open note?
You never have to ask, just take
An open note. This is not
perfect.
test.
Don't you worry.
Star, is this an open note quiz?
Yes.
Oh,
Oh, she's not in our class.
You just noticed that?
Yes.
Where'd Hannah go?
Oh yeah,
okay.
she said
I mean, it's weird. Honestly, I don't know half the people in this class.
Ew, the grape is still over here.
Hi, my name's Elena.
Well, if it's on the floor, don't worry about it.
Everyone in this row, these rows,
Alright.
If you're afraid of the grape.
these
These
two,
were-
Colton over there.
Works for me.
Everyone-
Okay.
I don't
So
know.
I think you will all appreciate this unit. This chapter 9 is in your book, so I don't have to give you a big old thing of worksheets. At the end of this unit, we have one of those fantastic capstones to take, which you will all do very well on. And you will all get extra credit. I have full faith.
it.
Oh my goodness.
I think you did. I don't remember. I gotta look.
It was with the derivatives, like the fraction of the. Yeah, I think I did.
All right. So
Like, I love that.
I took the cap.
here we go. Here is a real life thought. I'm sure you all have heard this little story that someone comes and says, "I'll give you $10 million to do something, or I'll give you a penny a day, and I'll double that penny every day for 30 days. You want the 10 million, or you want the penny a day doubled every day?" And the thing is, the penny a day doubled every day. So someone says, "I'm going to give you a penny," so you get nothing here. You get a penny on the first day. On the second day, you get 2 pennies. On the third day, you get 4 pennies. On the fourth day, you get 8 pennies. On the fifth day, you get 16 pennies. So this is called an exponential growth. And technically, this is supposed to keep going this way forever, but we don't have, days that don't exist. Okay? So yes, if someone ever offers you a penny doubling it every day for 30 days, make sure you get the contract in writing, because they're going to allow you to make enough money after 30 days that you get to retire.
Wait,
much money do you
would
get?
that be?
A lot.
Quite a bit.
You don't know.
Or just
quite a few.
We got a big calculator?
I got a graph.
Yeah, that's what I would think.
What's the arithmetic sequence?
I would love this actually.
Arithmetic.
I really need to.
Arithmetic.
No, arithmetic is a noun. Arithmetic is a verb. My acoustic.
Yeah.
Oh my god.
I mean,
I'm gonna
technically.
Oh, okay.
What?
I feel like I'll be back. I'm like, wait.
There's arithmetic.
Arithmetic.
Because it's different when it's a verb and it's different when it's a noun.
Okay, but that's gross.
I'm sorry.
It's
I
different than
didn't-
geometric because
I really wanted to.
it depends. It's complicated. When it comes to English, a lot of things. Specifically, when it comes to arithmetic versus arithmetic, it's this specification on arithmetic, geometric, those things, that specification. Arithmetic, not monotic.
What are you doing?
Because that's just a colloquialism, but it should be pronounced arithmetic.
So, well, no, because people will pronounce it arithmetic. And that's just a colloquial say. Because that refers to the noun. Arithmetic is a noun. Arithmetic. Or noun. Is the verb. So arithmetic sequence is different than arithmetic. It's different than arithmetic. Because it's don't speak English. Like, this is English.
Okay, I won't speak it.
What are you gonna speak? I should have expected that, but I lost
Large number.
because you don't pronounce the L's. Because you're a Latin language, and I know Germanic and Semitic languages. Arabic, Hebrew,
31.
Oh, 31.
because there's
All right, so
Greek, Latin.
So we just came out, if this was 31 days, if this truly happened, it came out to $331 million.
Oh, no way.
Yeah. So get it in writing if someone says they're going to pay you a penny a day, doubling every day for 31 days. You would like own islands and stuff. It'd be cool. All right, so moving on. An exponential function that involves an expression is b to the x, b raised to the x power. So b is a number. It's a positive number. It's not 1. And an asymptote is a line that approaches as you move away from the origin. So as you move to the right or to the left from the origin, that's an asymptote. An asymptote on these will usually be a horizontal asymptote, at least for this chapter. Okay? But we'll talk a little bit more about it. All right, so let's think about how we can do this. So I'm going to graph this problem right here. And I am going to resort to my fancy-dancy t-table. And these are good values to start with. So if I have 2 to the negative 1, 2 to the negative 1, that's equal to 1/2.
Yeah.
And then 2 to the 0 is 1. 2 to the first is 2. 2 to the second is 4. So this is going to be my parent function. So at negative 1, I'm at half. At 0, I'm at 1. At 1, I'm at 2. And at 2, I'm at 4. Now, this right here, this dotted line right here, is our asymptote. And then how I know it's my asymptote is that's plus 0. So the asymptote, if there's nothing being added or subtracted, is just the x-axis. So this graph actually looks like this when I graph it. Okay? So it grows pretty quickly. Now notice I didn't plug a lot of values in. Okay? Negative 1, 0, 1, 2. As far as our parent function goes, that satisfies more than enough. Okay? So let's graph this one. So this is going to shift up 3. So not only does my graph shift up 3, but my asymptote as well. So my asymptote comes to here. And then I'm going to go to this point. This point shifts up 3. 1, 2, 3. This point here shifts up 3. 1, 2, 3. This point here. 1, 2, 3. This point here. 1, 2, 3.
Whoa.
Does that seem okay so far? So in that, most of these, if you put the parent function in, which is the basic version of it, if you graph that first, you can do all of the shifting without ever doing another t-table. Annie, do you have a question?
Where's your asymptote?
My asymptote on this one is at 3. So it's the line y equals 3. That's my asymptote.
Okay.
Okay? Because it's plus 3. Because the plus 3 was outside.
Okay.
This one, my asymptote will still be back at 0. So y equals 0 will be my asymptote. This is like it's grouped. So this is not going to shift it up or down. This one's going to shift it to the right because it's negative. Shift it to the right because it's negative. Okay? So my asymptote's still here. Thank you. That's my asymptote. Okay? So I'm going to take my original thing. Which way did I say it's shifting? How many? 3. So this point's going to go 1, 2, 3. This point's going to go 1, 2, 3. This point's going to go 1, 2, 3. And this point's going to go 1, 2, 3.
What's up, Megs? How are you?
Yeah,
No, it's perfect.
Okay.
It's better for me if someone takes it because you know me, I will trip over it.
And we have to laugh.
So I appreciate you looking out for me. Thank
No
you.
problem. No problem, sir.
Hers exploded in Spanish.
Oh yeah.
Don't get the whole. If you just like squeeze it, it comes out.
May I move to the next slide?
C.
Oh yeah.
Yeah.
I think you might have already covered this, but where do you get your numbers from the t-table?
I just had to start someplace, so I think negative 1, 0, 1, and 2 are fine to start with. Sometimes they might shift around a little bit, but as far as the parent function goes, once you have the parent function graph, those should work all the time.
Okay, so then you just put the negative 1, 0, 1, and 2 in for x and then solve for 1.
Mm-hmm. Yep, that's exactly right. So this one has a parent function which is 2 to the x. I don't have to be 2 to the x. It could be 3 to the x. It could be 10 to the x. It could be 50 to the x. But your parent function could, that's the most basic without it shifting right, left, up, or down. Okay? May I move forward? Would you guys please pay attention?
Yes.
That's a lot, guys.
Ready?
If you with an exponent of 0, it's just 1.
1. A number to the 0 power is 1 unless it's 0 and then it's undefined. But we shouldn't run into that on these.
Okay.
All right. Same parent function as before, but just for good sake, we'll say -1, 0, 1, and 2. 2 to the -1 is half. 2 to the 0 is 1. 2 to the first is 2. 2 to the second is 4. My asymptote is going to be still 0. Okay, because I did not add it or subtract anything from the very end. So I have -1, half. I have 0, 1. I have 1, 2. And I have 2, 4. So that's what my parent function looks like. And that's my go-to every time. I will put the most basic parent function graph on the same graph that I'm graphing the other stuff. Because once you do that, and you have points that you can see, you can do everything else without ever having to do another t-table. Okay? So let's think about what this one does. What do you think the asymptote should be? Am I adding or subtracting anything to it?
Subtracting.
I have a negative in front, but am I subtracting? You're right, there is a subtraction sign, but am I subtracting anything back here? No. So this is still my asymptote. Okay? Now, we can do this. Let's think about this. If I plug in any of these values, they're not being interfered with, but my y value is. My y value is going to be what? Negative. So this is not going to be here. This is going to be down here. Okay? This one isn't going to be here. It's going to be here.
Like a reverse.
This one isn't going to be here. It's going to be down here. This one isn't going to be here. It's going to be down here. So it flipped over. So this flipped vertically over the asymptote. Notice I didn't say the x-axis. Yeah.
Why is 2 to the x the parent function?
Because this case, it's the most basic I could do. So they're taking the same. So we have 2 to the x on all of these, but that's the most basic. This one doesn't have any of the shifting or the flippings.
Okay.
Okay? Let's graph this one. Let's take care of the asymptote first. 1. Is that okay so far?
Yeah.
Okay? And again, I'm not redoing a t-table. Let's think about the shifting. So I'm going to add 1 vertically. Okay? So that's to my y values. What is this going to do?
Go right 3.
Right 3. Good. Okay, so we're going to keep that in mind. I've just written my rules down that are going to take place. So I'm going to go to this red point because that's my parent function. So this red point is going to go up 1 and then what? Right 3. What about this point? It's going to go up 1 and over 3. What about this point? It's going to go over 1 and up 3. Whoop. Up 1 and over 3. This one's going to go up 1. And there it is. Friends, should I make a whole new t-table?
No.
No.
You want to finish that, Owen? Yay! Any desk that's open is yours. Can I move to the next slide? Okay. Parent function still the same, yes?
Yes.
Now the reason why a lot of times we're staying with the same parent function is exponential functions grow very rapidly. So we would run out of graph space real quick. Does that make sense? So again, so we feel good about this. 2 to the negative 1 is 1/2. 2 to the 0 is 1. 2 to the first is 2. 2 to the second is 4. Asymptote is here. Negative 1 to the half. 0 to the first. 1 to 2. 2 to 4. There's the parent function again. Maybe make our dots a little more pronounced. Okay? What do you think's happening here? I'll tell you, it's only happening to the y, so what do you think? Yeah? Uh-huh. Yeah, it's a vertical stretch by 3. So I'm going to multiply y by 3. Okay? I can do that. Still the same asymptote. If I multiply half times 3, I get to 3 over 2. 3 over 2 is 1.5. Right?
Yeah.
If I multiply 1 by 3, 1, 2, 3, bless you. If I multiply 2 times 3, 6. If I multiply 4 times 3, that's it. Two things are going to happen to the next one. What does that 0.5 do? The 3 did a stretch. What do you think 0.5 will do? Yeah. Vertical shrink. So we'll call it a compression. A compression. I like vertical shrink as well, and I'll give you total credit for that. By 0.5. And it's also going to do a vertical flip over the asymptote. Is that okay? So, my asymptote is still going to be the same. Okay? I'm going to come to my original green point. I'm going to multiply half times half. So I get 4th, and I'm going to make it negative. It's right there. Is that okay so far? Does everyone feel okay that I went half times half? Half times half, a 4th, make it negative, negative 1/4. Okay, next one. Half of 1, half, negative half. Half of 2, 1, negative. Half of 4, 2, negative. Grew away. This seems like much nicer math.
I agree. Does it?
Like, I feel like the pressure of the class is like, but you're also kind of like, all right, it's stirrup. He's got some curveball that's coming. Nah, we should be all right. We should be good. Can I move on? Oh, now we have a parent function of 3 to the x. Did you get it? I'll get that submitted for you. Negative 1, 0, 1, 2. Asymptote still going to be here. Okay? 3 to the negative 1 is 1/3. 3 to the 0, 1. 3 to the first, 3. 3 to the second, 9. Agree?
Yes.
3 times 2?
3 what?
Is it the second?
To the second
Oh, no,
part.
yes, never mind.
All right. So I get negative 1, 1/3. So that's somewhere here. I get 0, 1. I get 1, 3. I get 2, 9. So that's that parent function. So it looks the same, right? It just grew faster. Blue one, asymptote?
That grew fast.
Yes. What's my asymptote on the split next one?
It's the same.
Same spot? Cool. Okay. It's going to do a vertical stretch. Stretch. I can't spell.
2.
So, yes, good.
Good.
So I'm going to multiply my y values by 2. And then what is this going to do?
Left 2.
Good job. Left
Filled it.
2.
Cheese Pete. Cheese Pete.
Ready? Think we can do this.
Oh, yeah.
All right. Starting here.
Yeah.
I'm at 1/3. I'm going to double 1/3. I get to 2/3. Yes?
Yeah.
2/3 and shift left 2. It's about there. Is that okay? Okay. Let's go to this point. I'm going to multiply by 2. So I get to 2. Shift left 2. I'm going to go to this point. 3 times 2, 6.
Yeah.
Shift left 2. Go to this point. 18. So it's up here. Shift. How many 2? 2 left. Oops.
Gotta be on the 0.
It's somewhere. Let's pretend that's 18. There it is. I think that one kind of grew really fast.
Yeah, I think it did.
That's the kind of money you want to make.
That's crazy.
Asymptote on this one?
0.
Still 0. Cool. Notice each time I'm drawing in an asymptote. Okay? So this is going to be a compression or a vertical shrink. So multiply, and that's in the vertical, multiply by 0.5 times y, and I'll say it's negative, and that means it's going to also flip over vertically the asymptote. Okay? So what's going to the black graph? Ready?
Mm-hmm.
So that was half. Half times half, fourth. Fourth times negative, negative fourth. That's 1. Half of 1, half.
What? Oh.
Half of 1, half.
Yeah.
Half negative, negative half.
Wouldn't the 1/3, if we cut it in half, would be 1/6? No, not 1/4. Because it's 1/3. And if you cut that in half.
Oh, it is. It's 1/6. Yeah, so 1/6 right here. Good. Fortunately, my graph, my dot's big enough that I think it covered both. Good, but good catch. Good catch. All right. 3. I'm going to multiply 3 times half. 1.5. 1.5. Make it negative down here. This one. Multiply 9 by 0.5. I get 4.5. So I get negative 4.5. Somewhere down here.
Yeah, probably.
There we go.
Any plans this weekend, Syrup?
I think I'll sleep in tomorrow.
Retweet.
Make it to
Yeah,
about
same.
make it to about 6:45 in the morning.
Oh wow.
6:45. That's all.
That's
That's
sleeping
really.
games?
That's
Like,
late, Stirrup.
I don't even get up. I get up at 7:30 on school days.
On 7:30 at school.
I get up at 5,
Sam told me to do that, and then I don't understand why.
and then I leave here. I leave my house at about 5:25. I'm here by about 5:40.
Why?
Because there's nobody on the road.
I know. Isn't that nice?
And nobody's on the copy machines. And it's quiet.
It's creepy.
And I get all my
not-
grading done
It's
and all my
so
copying
scary.
done.
Yeah, I get up at.
I was only scared the first year. After that, I kind of.
How do you?
I guess that's what makes you an issue. Yeah, I have a first period, but I get up at like 7:30, 7:45.
All right. So generalize. I don't know what this one is. I'm just gonna leave that one blank.
Nanny, nanny.
All exponential functions y equals a times b to the x will have an asymptote at y equals 0 because I didn't add anything to it. All exponential functions as y equals a times b to the x will have a domain. The domain will be negative to positive infinity. Because I'm not adding anything to it, it will have an a range from 0 to infinity. Okay, and again, notice that I don't have any signs that are negatives or anything like that. It's a rounded bracket at the 0 because it's an asymptote. We approach it. Can I move on? Okay, how do we generalize this? Okay, so this, if it's if negative h, right h, if positive h, left h. Okay, asymptote, not changed. Domain and range pretty much stay the same. They pretty much stay the same as what the parent function does. To me?
Yeah.
I don't want to get all your pictures.
You won't. I can say that you don't get them.
Okay. Hey, get home going, what are all these pictures?
That'd be.
I have a.
I got like 7 pictures.
I have a charger. I just don't have a
Awesome.
box.
Oh, I have a box.
Can I use that?
Yeah.
Okay, cool.
Okay.
How do we generalize this?
Oh.
So, if k is positive, up. If k is negative, down. Asymptote moves up or down
Ow.
k units. Domain and range. Domain doesn't get affected. Domain stays as negative to positive infinity. Range, look at new asymptote.
I'm sorry. You have to grade this. That's all I have to say.
I'm happy to do that for you.
That I feel that. That was a hard quiz.
Yeah, that was a tough one. Hey, where's Naomi? Oh, girl, where's she?
May I move on?
Yeah.
Okay. So, we got a few minutes. Well, I got this, that. Okay. All right. So, sometimes when we ask you to find the graph, panic sets in. I think this is the friendliest type of find the graph, or find the equation from the graph that there is.
Speak of the level. Oh, gotcha. I said, where's Naomi? Oh, like literally 1 second.
Yeah, like literally.
Okay, ready? So, first thing I want to ask you. from our parent function, which we usually start here, how far to the right did I move with the starting point? 2. So I went from here to here, so this is the new starting point. Okay, so that means that my h value had to be a -2. Okay, but I don't want us to panic with this. I just want us to kind of keep that in mind. This appears to have an asymptote of y equals 0. Agree? All right, so let's see if we can figure out this problem. So I'm going to use so let's start filling out what we might know. What would my k value be on this graph?
-2.
K value, not h.
0.
0. Everyone feel comfortable with that?
Yeah.
So I can kind of ignore that now. So I'm just going to say, well, that's nice that we have just that 0. So I'm going to just have this now. Is that okay?
Isn't it -2 for the h?
Yeah, we're going to get there. Yeah. Okay. So if we look back at our original graph, my original point's usually over here and somewhere around here, but this was a distance of 2. So I think my h value has to be -2. So I just plug 2 into that equation. Because it went right.
Well, yeah, but you said if it's a -2, then wouldn't it be +2 if it's -h?
So that's like it's grouped. So it'll shift opposite. Okay? But good thought. Okay, so now what I want to do is I just want to look at two of the points. I want to look at the point 1, 1, and I want to look at the point 2, 2. Seem okay? Which one of those points seems like totally friendly?
1.
1, 1, all day long. So I'm going to use 1, 1 to start this. Okay? So this is an x, this is a y value. So I'm going to go 1 equals a times b, 1 minus 2. Is that okay?
Yeah.
Which means I have 1 equals a times b to the -1. Is that all right?
Yeah.
Which means a is equal to b. Now let's see if you can see why that happened. Yeah.
Because
Transitive property.
Kinda.
a negative exponent creates a fraction, so it's 1 over b, and then you multiply b to get it to the other side. B times 1 is b, so b would equal to a.
Cool.
It's Jacob.
So that happened because b to the -1. So a over b, b equals a. Looks good. So we're going to have the same value, which is fine. All right, I'm going to pick my other point, 2, 2. Pick my other point, 2, 2. So if a is equal to b, which is fantastic, let's see if this is going to work. I'm going to go 2 equals a times b, 2 minus 2. 2 equals a times b to the 0.
So 2 is equal to a.
So a is equal to 2. What do we know from here?
B equals 2, A equals 2.
Yes.
So a equals 2 times 2 raised to the x minus 2, and my equation's done.
It really was the transitive property, right? Because that equaled that, so that. That's my favorite property.
6 minutes to do that.
All right. So things we got to know about this one. All I'm going to do on this one is I'm going to focus on the points. Is that okay?
Yeah.
So I want to go to, I can't go there. I'm going to just, would somebody tell me what my 2 points are? What are my 2 points?
-2 negative 3.
Have you yeah?
Negative 2, negative 4.
Go ahead.
Negative 3, negative 3.
Negative 3, negative 3.
Negative 2, negative 4.
Negative 2, negative 4. Good. Okay. What does it appear the asymptote is?
2. Negative 2.
Agree?
Yeah.
So the asymptote appears to be negative 2. So my k value, needs to be negative 2. Because that's my asymptote. K value equals negative 2. Ready? My general equation is this. A equals A times B raised to the x minus h minus 2.
Spooky.
Good? Let's look at what the h value is. I do have this point right here, right?
See.
I do have that point right there. It normally happens at negative 1. That one's happening at negative 1. I'm happy about that. I'm happy about that. So I'm going to use negative 1 comma 6. I'm going to cross this one off. Negative 1 comma 6. Is that okay? Or comma negative 6. So it doesn't appear that it has shifted right or left at all. Correct?
Yeah.
Because on our normal parent function, it normally was happening at negative 1 as our first point, and that one seemed to do the same thing. It is, so here, a negative 1 as my first point. So that's what I'm thinking. Now I know it's kind of changed directions and stuff, but I think because it's negative 1, we're not having to move it right or left. So we're not having to move it right or left. What becomes 0? H? Is that okay? Okay? So let's pick one of our points. Let's pick this. That's an x and a y value.
Sure.
So I'm going to get negative 6 is equal to a times b raised to the negative 1 minus 2. Oh, sweet. I think I kind of solved this. So that works. What about this? Does this work? Does that work?
Yeah.
Yes.
That means that negative 4b is equal to a. Because we have to remember the b to the negative 1 is equal to 1 over b, right?
Yes.
If I just multiply both sides. So let's hold on to this. What was the other point I wanted to use? Negative 3, 3? So so I'm going to use this right here with negative 3, 3. Negative 3 equals a. What did I just call a? B raised to the x, which is negative 3, minus 2.
Jesus Louises. You add that, you get negative 1. You combine those, and that's.
And then
gross.
what did I do?
Well, you'd have to combine the b's, and because
Yeah,
b is
'cause-
raised to the first power, you get a negative 2, and then you put that
Cool?
b to the second over 4. Did you divide that by negative 4 first?
2.
Or negative? No, it's not.
Cool, I like it.
Wait, isn't it plus or minus 2?
Let's hold on to that thought. Let's see if we need that. I like your thought, but let's see if we need it.
Like my
All right, ready? So if that happens, that means a is supposed to be negative 8. If that happens, that means a has to be negative 8, yes? There's my equation.
Hey-oh, wait. That's cool. Wouldn't that
Holla.
be just, wait, wouldn't that be negative 16 raised to the
It's
first
Tuesday,
power?
Sarah.
No, because
Oh, it's a different
order of operations. Friends, your homework is in your. I gotta remember what page it is.
9A, every other
66.
9A, sounds good. Yay!
Every
Thank you.
other even because it's my birthday.
Oh, Jacob!
How about that?
Happy
Huh?
birthday! Jacob, happy birthday!
Even today's my 1 year anniversary.
Bye, Dora.
9A evens. 9A evens.
This is the worst birthday ever. It's even worse than that time I got shot.
You got shot?
I got shot.
That's so cool, dude. I wish.
No, it's not. It really wasn't.
But like when you get shot.
I got shot with an arrow.
That's kind of funny.
Was my older brother an asshole? I wasn't that sharp, but it still penetrated the skin and left a nice
Haha. You're so funny. I am the older brother. So.
Thank you.
Yeah.
You got it. Have a great weekend.
Let's go, shall we? Brendan Bundy. Wait, Gavin, what's her name?
Thank you.
Wait, your name is Brendan Bundy?
Mr. Stork.
Yeah.
I didn't do like too well on the previous quiz that we had like before this one. Can I like see what happened?
Yeah, you want to do it now or you want to?
Or no, just like later.
Yeah, anytime you want to come back, including now if you want. Hey.
I'm just gonna let you know that I will be coming in on Monday, second period, to finish the test.
Perfect. Works for me.
Okay, thank you.
Thanks so much.
Did you see that?
That was really good.
No, I wasn't. Sorry.
Happy day.
You too, thank you.